dx. Could you please draw the graph of the region that I'm interested in finding the area of? By the way, this would be convergent, all I wrote it to. Losing my mind. What's the improper part of this one? Infinity, right? If you remember, fundamental theorem of calculus says it's got to be on the closed interval. Infinity for sure is not closed. Closed implies that we're including that last point. We are definitely, there is no last point in this one. I often get students who ask me, when would you ever have infinity as a boundary? Actually, in physics, all the time you do that. If you want to say, what is the complete gravitational field of like the Earth or something like that, you need to go from the center of the Earth off to infinity as far as distance goes, and that gives you the entire gravitational field. Okay? Because if you don't know this, you'll learn this eventually, every mass in the universe has a gravitational pull on you right now, actually. The person next to you, the Earth is the strongest because it's the biggest, the moon is pulling on you, nearest star is pulling on you, the next nearest star is pulling on you, the desk is pulling on you, this pen is pulling on you, everything has a gravitational field attraction towards one another, as far as matter goes. So if we want the totality of that, we have to have it go off to infinity. So that would be one example. All right, let's figure this out. At this point, it's a crapshoot, right? We don't know. It might be convergent, it might be divergent. Logic would tell us it should be divergent every time if we're adding up an infinite number of pieces. So we'll see. Meaning, I'm grabbing letter t like this, and I'm just integrating from 1 to t, which is fine. And when I'm all done with the proper integral, let's take t, we'll throw it off to infinity. Natural log of 1 is 0, right? So the proper integral gave me the natural log of t. You can put absolute value if you want. We're starting at 1 and going up to infinity. It'll never be negative. Now we've got to figure out what happens to this limit. As t gets larger and larger and larger, what's happening to the natural log of t? Picture the graph. What's the graph doing? It's going off to infinity. Natural log of t looks like this, right? It's slowly going up to infinity, but it's still getting there. Yeah?
Does it matter if the infinity is approaching from the left or the right? On the t approaching infinity?
That wouldn't apply in this case.
It wouldn't apply.
No, we're just saying t, take it off to infinity. We only do that when we've been asking to it, we're trying to get closer and closer to it.
Okay.
From one side to the other, for this particular context. So what does this become? Which means it's divergent. Meaning there's an infinite amount of area here. It just keeps growing. How are we doing? I'm going to ask you to take this improper integral and integrate it determine if it is convergent or divergent. And if it is convergent, what does it converge to? Converges to 0. I doubt it will be 0, but we'll see.